I'm Thomas. I'm really excited to be here today and really happy to see that so many people showed up. I have come from Norway to the United States this week. Been to the summit yesterday and earlier today, and been lucky enough to be able to talk to you about demo application that we in Vespa have been working on for the last couple of months. First, let me introduce myself briefly. I'm a senior software engineer working at Vespa AI. I come from Norway. Our whole engineering team at Vespa AI is based in Norway. And Vespa is actually, so now I do it there works. Vespa is actually an open source search engine. So we have earlier been a part of Yahoo, powering Yahoo's search and recommendation and personalization use cases. We were spun out as a separate company about a year ago. Now we have a lot of customers using us on Vespa Cloud to host their search solutions. Some of the more known customers are Spotify, Perplexity, Ravenpack, Pinted, and so on. Yeah. So today, this is the agenda that we're going to go through. First, also, let me tell you about the QR code. If you scan that one, you will get access to the deck. It has a lot of useful links that you probably want if you're going to try out some of this stuff or want to look up some of the sources and so on. So do that. And I think you need to put in some info so that our marketing team actually gets to see that somebody has actually been here and registered and have someone to send out the content to. All right. So the demo application that I will demonstrate to you is because we developed that in order to address a problem. And that problem, actually, before I joined Vespa, I worked on that problem personally with a client implementing Vespa, where the problem was that they had a bunch of PDF documents. This was in the construction business. They had a lot of documents related to maintenance and operations of buildings, manuals, and so on. And they wanted to make these documents searchable for their building operators. So we were talking about hundreds of thousands of PDFs, which previously had been just in a directory folder and not searchable. Yeah. So yeah, let me go on, and we will get back to the later points of the agenda as we go. Yeah. So searching PDFs, that's a really common problem. Almost any business enterprise, they have some documents, some archive in some source, and a lot of the documents are stored as PDFs. It's a common storage format for a lot of people. So what do we traditionally, how does this PDFs usually look like? It can be diagrams, it can be images, it can be tables, it can be signatures, and it can be charts. And if you're looking for this information, how, if you're just extracting the text from this, do you think you will lose a bit of the information that is needed to answer questions related to this PDF? Yes, you will. So the thing is that a lot of the documents that exist in the wild are of a complex format. It has visual, infographics, tables, and so on. So what has traditionally been used is to set up a document or text extraction pipeline. And that's also what I started to do when I worked with this customer earlier. So then you have a new set of problems. You need to extract the text, and that might be difficult. If you have simple Word documents, you can extract the text quite nicely. If you have scans, if you have handwriting, you need to do OCR, and that might be a pain just to orchestrate. You need to use tools like Textract, Tesseract, Unstructured I/O, Azure AI, Document Intelligence, Apache Tika, and so on. So there are a lot of tools. Many of these are not requires, it adds complexity to your solution. So it requires a lot. And this extracting the text correctly from the document, that's actually very often the performance bottleneck for document solutions. So then it doesn't matter how good your search solution is unless you're able to actually extract the text that it contains. But if you are lucky enough to extract the text, then you can index it, make it searchable using traditional text search approach, keyword search. You can also do embedding retrieval, hybrid search, semantic search, or you can use displayed, BERT, Colbert, and so on. All of these work on text only, and they work on the text that you're lucky enough to have extracted. So bottom line, the problem is text extraction is messy. It's hard. If you see this sample here, you see that what is shown here, that's an embedded image. So that you can just forget to extract anything from that. You see other parts of the documents, you see here nature. So basically the two words here has been concatenated and into one word. So if you search for sustainability here, you're not sure to match it because it's extracted as one word. Stuff are out of order and so on. This is a very common problem. So, is there a solution to this? A very, very promising direction is what we call visual RAG. First, let us summarize what is RAG. Probably most of you know, but RAG is an acronym for Retrieval-Augmented Generation. So basically, if you have a user that has a query or a question, then you need to retrieve a bunch of documents. You would like to retrieve the most relevant documents. And then you pass those documents as a context to an LLM, which then can, to a large language model, which then can answer these questions based on the retrieved documents, right? So this is RAG. And this is vanilla RAG that works on text. So then you can do the retrieval of the documents. It can be done in many different ways. Vespa supports a lot of different ways to express the ranking expression that will define how your documents are ranked, which top K documents are ranked. Here you can do BM25, you can do single vector embeddings, you can do also multi-vector for Colbert style embeddings, for those that heard about that. But in contrast, visual rank is quite similar, but instead of extracting the text, you skip the whole document text extraction part. Instead, you can use a VLM, vision language model, to create embeddings of the images directly, and you can index those vectors instead of the text. You could do single vector embeddings, so that means that you have one image and the result is one vector. That will work for some use cases, like if you have if you want to do image search, so you search for a cat and then you want to find the images that has a cat in it. For that, single vector images might be good. But when you have complex information like this with a lot of text as well, then you would want to do multi-vector, Cole-Pally style embedding. So I will get a lot back to Cole-Pally and that model and direction soon. But in the same way, you can retrieve those most relevant images. You can pass those along to a vision language model, which then answers the questions that the user asks directly based on the images. Right? Just a little side step. A vision language model is a multimodal model that can learn both from images and text. And when you create an embedding, you can choose to do it either from an image or from a text, and the embedding will be in the same space, so that you can do similarity search across modalities. You can search either for you can have a query that is text and then retrieve images, or vice versa. This is real slow, this clicker. I just bought it today. I think I'm gonna ask for a refund. Okay, so I mentioned Cole-Pally. That's one type of vision language model. Or actually, it's not a vision language model in itself, but it's a fine-tuning adapter version of a vision language model, which enables so it uses the underlying large vision language model, and then you with a Cole-Pally adapter, you can use this to extract multi-vector embeddings. And I will explain a bit more what I mean by what exactly these multi-vector embeddings will mean. So Cole-Pally, that's an acronym for contextualized late interaction over polygemma. So polygemma, that's a VLM, that's a visual language model, in the same sense that some of the Llama 3, Llama 3.3, or Gemini, or it might be GPT-4o, right? So it's just that they used this one in the paper that introduced this this technique. And contextualized late interaction. Some of you that have heard about Colbert earlier, you might recognize that exactly terminology, and it's the same technique here, that you actually have the contextualized embeddings per token. And this is really, really exciting direction because it performs a lot better. And it's also shown that these frontier VLMs, the best ones, they actually answer questions a lot better when they are given the images directly rather than using OCR or optical character recognition first to extract the text. So the performance you can see here, if you feed the extracted text to a document versus if you're feeding the image, the feeding the image provides a lot better results. So how does actually this method called Pally compare against traditional methods? There are benchmarks for this. They introduced a benchmark which is called VDORE, or short for Visual Document Retrieval benchmark, with a set of data sets where you can see here the performance if you do different style of methods for text extraction, and then use BM25, which is a text matching algorithm, or if you use one of the top performing single vector embedding models for text, which is BGM3, you have average 65, 66 score here. With Cold Pally, average 81.3. So it's a really big gap in the performance for these types of documents when you use a visual model to compare the vector similarity for that compared to using the text. This is a significant leap in performance. So with this method, you can do matching without, you can skip actually the whole complexity of the text extraction. You can avoid OCR, optical character recognition. You don't have to do layout detection and all this stuff to try to detect, okay, where are the tables, where are the headings, where are the charts, and so on. So it makes stuff a lot simpler. I'm a software engineer, and I like keeping stuff simple, avoiding too much complexity. What do you say? Multiple languages?
Different language.
Yeah.
Other than English.
Yeah, very good question. So we asked about multiple languages. If you have other languages than English, so then it will all depend on the model, right? So if you remember Cold Pally, that was used as one vision language model, PalyGemma, which has some multilingual capabilities, not very good, but some. But then you can also you have fine tunes on top of that, which can be tuned to any language. And that's quite simple. You can run that fine tuning in a Colab, in a Google Colab notebook. And there are recipes for that. So I'm not sure if there are already models that are trained for every languages. I don't think there's any for Norwegian yet. We actually considered doing it, but that's a bit out of our core area of focus. Yeah, but it's possible. This is a future direction. I don't think already this was published I think half a year ago or something, but already there have been, I think, at least 4 or 5 models that have overtaken Cold Pally on this benchmark leaderboard. So every time you get a new vision language model, you will probably adapt the new models that can do retrieval accordingly. So it's a direction. It's not like this model will be the one that solves this problem, but the method that was introduced here, we think is quite revolutionary. Okay, so how does it really work? When you feed an image into a Kolpali style model, it sees the image as 32 by 32, that's 1024 patches. Patches are, like you see here, it's squares that goes like this. So each of these patches can be seen as a token, similar to a token if you are in the LLM world, if you're in the text world. So each of these patches then get a 128 vector representation, which captures the semantic meaning of that patch. Yeah. And then, yeah, so then I think I will skip to the demo of the application that we made. We have a live running version of it that you are free to try. But I won't do that here now. I don't want to encounter the demo ghost, that we call it in Norwegian. I'm not sure if that's an English word. But what we did for this application, we wanted to really test, does this actually work in a real scenario? Can you create a visual RAG application that will both perform well with regards to quality, but we also wanted to test whether you can actually do this with a low enough latency, because we are very concerned with latency and performance. That's really important to us in Vespa. When you interact with the search engine, you expect results within 100 milliseconds is like the typical gold standards. So when you click Google, you want results fast. When you ask Perplexity, which uses Vespa for their index, then you wouldn't be satisfied by waiting a second or two before it starts giving you something. This is important to know whether it's usable. So the data set that we fed, we took about 7,000 pages, public PDF reports from the Norwegian Global Pension Fund, Government Pension Fund, Global. So this has the kind of documents that are really often what we're looking for, right? It contains aggregated info, has some infographics, some diagrams, some charts, and so on. And then we run these images through the Kolpali model, which gives us 1028 times 128 vectors per image. That may sound a lot, but we did some binarization to reduce the footprint. There are also other tricks that you can use to reduce the storage footprint. So the application is just a standard search application with one search line. Yeah, for those of you, if you want to try it out, if you have gotten the slide deck, you can click the link, but maybe you can test your OCR capabilities of your phone camera to see if you're able to copy the link from the image. That's also a possibility. Yeah, so that's also part of the reason why we wanted actually to create this demo, because very often Vespa, we usually only provide an API. We have an API to feed your documents, and we have an API to query your documents. But a lot of people, when we talk to them, especially business people, 5 minutes, 10, 10. Yeah. They are not satisfied with okay. They are not satisfied with getting a curl command that they need to run in their command line, and then they get some JSON output in their terminal. That's not really good demo for business people, right? We software engineers, we may think that's enough, but if you give someone a URL to a live application so they can actually test it out, tinker with it, they can play with it, then they are you put them in a lot better position to understand what's going on. So the application, if you search for something, then you get results, something like this. And there are a lot of interesting things going on here. So you ask for something, here's the query, right? You ask for number of graduate applications trend from 2021 to 2023. First of all, you see here that we enable 3 different ranking methods. Vespa supports what we call a rank profile. You can define as many as you like, I think. And the one that is shown there is hybrid call-poly plus BM25. You see this retrieved almost 2,000 documents in 0.152 seconds. It only returned as many as we asked for. I think we do 3 by default here, only because it's images and the user need to scroll, right? So this is quite good. And you see that we have a relevance score. And if you scroll down, you get even more results. But what's interesting here, right, is that the information that the user would need, or the model would need to be able to answer the question, what is the trend? What is the trend in the number of graduate applications here? That you can see here. We also did extract the text from these documents only because it was quite simple. It's a standard PDF format with text embedded. But then we see here the numbers. The numbers are in this diagram. They are just in line. So you have no idea. If you have just the text, you have no idea which one of, is it the blue or the black bar that represents the graduate applications. That's in the legend here. But this, of course, when you feed that to a VLM, so this is visual RAG. We take the top 3 images, feed it to a VLM. In this case, we use Gemini 8B as a VLM, and then it's able to answer the question accurately based on the image. This is a case where visual RAG is able to succeed. In a case where traditional text RAG would have no chance. There's another interesting byproduct of using this method. If you remember that the images are indexed with 128 dimensional vector per patch. You remember this, that there are 1028 patches in this image with a vector in each, right? And exactly for when you do the query, you also need to do inference of this call-poly model, and then you get 128 dimensional vector per token in the query. So we have the tokens here. That means you can actually visualize the similarity between each token and the image. That means you can see here, if you see graduate application, you see it highlights a bit where the word graduate appears here, and also in the legend. So that's interesting. Explainability, that's something that it matters in search, that you can see actually why is this image or this document retrieved. So here's just a toy example, and nobody wants to query for child jumping over puddle, but it was quite amusing to us to actually see where the token child is most similar to the image. You can see that it highlights around the child. If you select the token puddle, you can see that the puddle is highlighted. This is cool. It gives some understanding. Start to wrap up. Okay. I think I just skip ahead. We made this application. It's fully open source. You can have the code. Everything is only Python. We know that a lot of people like Python. I love Python. So that's why we built this whole, even the front end is built with Python. So if you want to know more about that, you need to check out our resources. We use something called fast HTML to build it. That's liked it much better than Streamlit and Gradio and whatever. This is the architecture, and everything improves. Benchmark improves, the models improve, but also the document methods, parsing methods improve. So basically, we think visual RAG is a really, really exciting direction that is going to be relevant for those that do document retrieval. But maybe vision isn't all you need for a complete search application, but it depends on your use case. All right.
Thank you, Joshua, for your time.
One question for just when you think of retrieval, usually we think of a transfer model. And BLM, I don't know what to do. That is all.
So the question is, when you think retrieval, you usually think about
transfer model, and that is cosine.
Cosine similarity.
That is so based on that, you can set the query, change it into vector. The context will be changed into vector. So you have the cosine and you re-rank it or whatever. But when it is VML, I don't know what to think.
It's basically the same concept, right? It's instead of the cosine similarity, you will do the maximum similarity. It's something called max sim, and so you do the maximum similarity of the token vectors over all the document vectors, image vectors, right? So, but the difference is that you will need to compare against 1028 vectors for each image, but the concept is exactly the same.
Thank
you. So, would you say compilation is best used for indexing only to get the embeddings, and then the completion step to synthesize an answer based on the image retrieved is best used with a model like Gemini or OpenAI, GPT-4o? And so this is my first question. I guess you kind of answered it with a yes. And then the second question is, if your database or knowledge base is consists of mostly texts, but only a small portion of images, would you still recommend to use compiling on the entire knowledge base versus segmenting different types of data?
Very good question. So for the first one, you asked you use Copilot style model for retrieval and ranking, but that's an important point. It does not have the VLM capabilities so that you cannot feed the images and expect a text response. For that, you need to use a different VLM, and the simplest is to use GPT-4o or Gemini or something with an API. Right? That's the first one. And the second one, if you have a large text knowledge base, but also some images. So what I would do then is to have query routing, so that if you do get some input query from the user, you would either you do it always, you can retrieve both from the text and the images, and then you can take that aggregated results and feed that to a language model, or you can have like federated search, so that you can maybe have a classifier that it does this query needs only the text-based knowledge base to answer the question, or should I also retrieve the images? So you can tailor it based on the use case. Yeah.
This one last question. We are running out of time. You can ask Thomas by end of the.
Yeah, you can also connect on. I have some contact info, I think, on the next slide, so you can also contact on LinkedIn and mail. But come on, go ahead.
So actually, I tested your demo.
Yeah.
I just typed the label. So I get the results. Is actually I was expecting some kind of, when you do the text search or the keyword search, you actually consider the titles. So the importance of the title. Yeah. But I don't see in your result, when you do the VLM, seems you are losing the context for the different titles.
Yeah.
For example, when I put the label, then I have the covenant.
Yeah, so the title using that one is not included in the context to the VLM in this demo. And that was intentionally. If we wanted to make the result as good as possible, we would naturally feed both the title, and we would also include the text, right? But then we would make it a lot easier for it for the model because we also did extract the text, and we could feed that one as well.
I can see you, because when you do the information, do the chat, because you search the chat, you use VLM, it definitely is better. But when you have the multiple maybe text, and you have the outlines. Yeah. For example, I have the covenant, then I have the label under the covenant. When I search, you cannot do it. Simply lose all this information.
Yeah, but you could also just include the text to the VLM, right? Because it's multimodal.
But you cannot control, because you use the VLM to do the embedding. Because you break them into the small image tokens. Yeah. So you are losing the information. But this, if you from the text model, it's easy to fit it.
Yeah. So what I'm saying is that you can actually take both the image and the text and get the both worlds, right? That's both worlds. So I think image or vision is not all you need. I think it's supplementary to text search. I think that's a good takeaway.
Thomas will be here for the networking event. Any more questions, you can reach directly to him. So let us invite our next speaker, Joshua from Weaviate.
Is this better? All right, cool. All right, so thank you, Thomas. Doesn't sound like it's on. Yes. How about now? Yeah. All right, cool. Thank you, Thomas from Vespa, for the great first chat of the evening. Hi, I'm Josh. I work at Weaviate, and in this section, we're going to be talking about the generative feedback loop. One thing to note, our demo today is interactive with a raffle at the end. So if you could please feel free to scan the QR code, fill out the form, and you can win this beautiful miniature, not the really big one, apologies for that, Millennium Falcon Lego. And I will keep to this slide, same QR code, same everything. So roughly for today, I'll give you a little bit about who I am, what is generative AI, and the generative feedback loop, why it's such a big deal, and how you can use it. Everyone good with the QR code? All right. Just a quick, brief safe harbor statement. What we are talking about tonight with the generative feedback loop is something at Weaviate that we see as the future. This is a pre-alpha. The direction of what we're looking at can change. I know for a fact our engineering team is already making changes to it. But anything you see here could change in the future about the technology that's underpinning this for this talk. So, like I said, I'm Josh Goldstein. I've been in search for about 10 years, all the way back to the Apache Solar days. I've done projects across various industries in the energy sector, financial sector, manufacturing. I really do love data and messing with data. Sometimes I like to go on weekend projects on my own personal data. And then from a hobbies and interests, in addition to long walks on the beach and candlelit dinners, I like racket sports, Star Trek, Star Wars, and all things vector database. So we're going to start with, how many of you know what the waggle dance is in terms of from a bee's perspective? Wow, that's really good. I'm going to have to tell my colleague who came up with the analogy. So my colleague who we wrote this together. We gave the same talk in Seattle last night. We talked about the waggle dance. And the waggle dance is basically a dance like this that bees do that has a direction and a distance. And what this does is it enables the bees to communicate with each other to point out where food is. Now, based on this food, based on these directions, and the distance in accordance to the sun, it will point and jiggle its way and face towards where the food is, and depending on for each second how many kilometers away that food is. Now, this is very structured. You have two pieces of data, a distance and a direction, but what happens if the bees could actually talk to each other as opposed to just wiggle around and point and distance themselves? And that's where the structured versus semantic comes in. So if bees could talk to each other, they'd have the ability to say, oh, this is a blackberry bush, this is the type of food, here's how many bees we need to go get that food. And that's where the semantic aspects of search and AI comes into play these days, because you're taking that structured data and you're conversing with it and making it into more unstructured and semantic data. So adding color, providing contextualization. What this also enables is that rich story. So now, going back to the bees, you can see if the bees were a semantic search, they would be able to have this full conversation around a more detailed implementation of going to find some food. So with the generative feedback loop, you ask, how do I turn the structured data into unstructured data? At Weaviate, we believe that as through working in the industry, as the evolution of vector search, RAG, agentic RAG is all coming into play, you started at the vector search, moved your way to RAG, and now we're getting into trying to start answering questions and trying to understand semantic meaning from data that's not necessarily or historically been able to be made aware of. And that's where the generative feedback loop comes in. So the generative feedback loop would be an LLM that is brought to the data as opposed to bringing the data to the model. So you have that all co-located where it's nice and fast and you're not breaking any security violations. By ability to set multiple data enrichment fields or multimodal aspects as well. So if you wanted to even do, I know with Thomas, and we were talking in his talk about some of those images, being able to take that image, run it through a feedback loop, and provide things like a risk assessment score, what types of animals or people or what types of objects are in an image. And this is a big deal because basically you're starting to formulating things and taking some of that unstructured data like financial transactions, or maybe you have a product catalog of just images, you just finished a photo shoot, now you need product descriptions, tags, etc. for that catalog itself. What else this also does is it increases the precision because you are augmenting the data. So by augmenting the data, you're giving it more contextualization so that when a user goes in and asks in a RAG, an agentic RAG perspective, you get that Q&A and you'll have that better response. And I'll show you that in a minute with the demo. So how can you use it? So how you can use it is, and this is using in Weaviate in our Python client. Basically, you have a prompt that you can define. And then within a method, you come in and you can set the properties. So Weaviate is a vector database, similar to Vespa, OpenSearch, Pinecone. So in that NoSQL format, basically you'll have the ability to choose which keys that you want to use from those documents to add into, to be leveraged as the information for that augmentation. So I set my fields and then I set my data type and my property name. So I would be setting the new field name that I want. And then within Weaviate, do all the, to support the various different data types, integers, dates, text array. By setting it as a text or even a text array, the feedback loop will know to spit out, if it's an array, a list of values, not just one long string for that field. The next section, the next step in this, and this this is really experimental, is the agentic GFL. So starting to add that agent aspect. I know the whole year, the trend, everyone's been talking agents. So here we are with agents. So with the agentic GFL, you have the ability to not only augment the data, but when you're querying, it will be able to come back, ask the database the question again, validate it, and then eventually even go into tools calling, like for instance, going out and doing a web search if there's not enough contextualization, or my favorite one, which one day I'm just gonna have every robot I build order me an Uber and pizza. So in this scenario, and this is from our preview that we got to see, you can see that we'll have the agentic query with a bunch of various aspects of it that you'll have control, especially focusing on that functions where, similar to the other agentic function callings, is the function call. Demo time. Does anyone have any questions before I go into the demos? Okay, so here is your one last chance if you would like to enter into the raffle for the Millennium Falcon. I will wait a minute for people. I do not see anyone's phone, so all right. So I'm going to show you two different use cases today. One is going to be with actual some mock data in the financial realm. And then the other is actually going to be deciding who gets to win the prize in the crowd tonight. So coming into my notebook, starting up at the top, simply using the Weaviate Python client, I'm connecting to my cluster, which is hosted in Weaviate's cloud. Oh, yeah. Is that better? And we'll try and get this guy. Get rid of this. Here we go. This guy can go over here. So here I'm creating a cluster, and if you're interested in trying out Weaviate, we do offer free sandboxes. You can go to our website, spin up a sandbox, and you can be up and running in about 5 to 10 minutes. So connecting to our cluster, then creating my collection, but we're going to change this back to trades. So we're going to create a collection, and in this collection, what we're going to be ingesting is a whole bunch of finance data. So just the date, the ticker, the percent change, the change amount, and if there's ever a note, some sort of note. Now, in a traditional search system, in a RAG, this is not the easiest type of content to talk to, because how do you embed numbers? They're numbers already. So what we'll do is, first we'll create our collection. Probably name it correctly, sorry. We'll create our collection. We'll import our data, which should take very quickly. We'll flush and we'll do a quick search. So now you can see I'm just doing one quick search on Apple for the Apple ticker. So you can see I have my ticker, my transaction, my date, my change, and my change percent. Okay, this is great. Now, in order to continue on this, and I really want to have a chat about this, what we can do is we'll add the GFL. So I'll start with my prompt. Using the provided trade information, give me a summary of this transaction. I'm setting a specific format and pieces of information that I want it to add into. In an ideal situation, it is not set up, it does have these features, but when you're building a GFL type mechanism for data enrichment, you'll want to be able to take the key pieces or fields from each document and put them in their strategic places, so you can actually inject the right information. In this example, we actually did kind of an old school search technique of concatenating all of the fields together. So it has one catch-all field to serve as your base search layer, but that doesn't have to be the case. So I'm setting my new property name, my data type, which is going to be a text field, the properties that I'm going to be leveraging of the documents, and then my prompt itself. So now I've started my process. And what's happening under the covers is at Weaviate, we have it as a managed service for our serverless offerings. And we're using a couple of technologies under the covers to help, one, save costs because GPUs are expensive, and two, to make sure that we have complete control over this. Now, the beauty of this is that I think we all recognized, or most of us recognized last night, that OpenAI went down for 4 hours. I definitely had a bunch of customers calling me saying, hey, what's going on? What's going on? And we're like, well, we can't really do anything about this. But by offering these types of services yourselves, you're able to keep that continuity. So if we take a look through here, as we can see, it's thinking really hard. So what it's doing is it's probably spinning up some infrastructure, getting the models running, and now it's actually running through that generation. And so if we keep checking, and this is where I start stalling time for the GFL to finish. This is taking too many seconds, a couple more seconds than I should. Yeah, it's not. Give it 1 second. I think as Thomas liked to say in his previous one, the demo ghosts was that one. Okay, we'll give it one more chance. And now it's completed. Apologies, it took a second. So now, if we come in and we take a look at our results, you can see now that we have a full trade summary. So when I did my search on graphics, none of these documents said graphics anywhere. You can see that my first results of transactions are NVIDIA, NVIDIA, NVIDIA. We keep going down, you'll see AMD, Adobe as well. All right, so that was the first demo. I got so excited, I dropped the mic. All right, for the second demo. For the second demo, what we're going to do is first we're going to come over into Google Sheets and see how many. Oh, wow. I like this list of people. This is awesome. So what we're going to do is we're going to be a little risky and do this in real time. So we're going to download this beautiful CSV file. I'm going to take this CSV file. I'm going to put it in my directory where we will be leveraging this. We'll come over here, and now we're going to come back up, and we're going to have an LLM decide which one of you wins the Millennium Falcon. So we'll start. We're going to do the same thing. We're going to create our collection. But now what I need to do is make sure I have the right file path. So now we'll put this in here. So we have our collection. We'll grab our data. And now we've ingested it. So now we can see that everyone has their list of users is in here. We do have a limit of 2. And now what we're going to do is we're going to have the GFL do 3 things. We're going to give a humor score, a creativity score, and an authenticity score. Please disclaim any of these notes. This is an LLM, so here we go with this. So what it will do, though, is, as you can see, one of the cool things is, though, I'm actually forcing it and telling the LLM, because I'm giving it the integer type, I'm telling it that, okay, this better be an integer or don't do anything at all, which is not what we really want. So we'll kick off the 3 GFLs. Once again, we're going to do a little bit of time killing here. Things are spinning up. Everyone, if everyone wants to raise their right hand for a second, put it across on your left shoulder. Now put it at your right hip. All right, you're all buckled up and ready to go for the winner. Let us check on the status of it. Thought I killed more time, but here we are. And what's happening is, there are a few more you guys than I put in my 3-term data set, in my 3-row data set. So this is going to take a second or two. You can see it's still spinning up and spinning up. My colleague assured me that this will work, because real-time demos, downloading data and ingesting it and trying to run LLMs on it all in a live session is always a fun one. Status is running. So as you can see, it's still running through it. We'll keep checking, and now it's done. So now, drum roll, please. What we'll see is the first person on the top that comes out is going to be the winner. So drum roll, the winner of the Star Wars Millennium Falcon miniature, not the really $1,000 big one, is Swati Gupta. Yay! And that about wraps it up for us, for me at Weaviate. Just like Thomas, if you're interested in learning about Weaviate, building on Weaviate, or just getting started on Weaviate, feel free to come find me after. Here's a contact us and a getting started. And thank you so much for your time.